Hello everyone. In this video we're going to go over Lab 4, but from the perspective of this week where we have subroutines, call stacks and all of this new information available to us. Now, Lab 4 asked us to change first of all a character to uppercase, write a little bit of code that did that, and then to write some code that would change an entire string to uppercase. So we want some code that checks every single character to say, is this an uppercase character? If so, leave it be. If it's lowercase, let's fix that. So before we get started, because I think I'll upload this in lieu of a Lab 4 explanation because we'll do the work as well here. But before we get started, let's have a look at the ASCII table. So how do we know is a character lowercase? Well, the key thing to remember is that a character is just a number that we interpret as a character later on. So let's have a look here. Let's see when a character is lowercase. You can see we've got the lowercase alphabet here. So a character is lowercase if it's between the hex values of 61 and 7a, because that's where the lowercase alphabet lies, or you could say 97 to 122. So the lowercase alphabet lies here, so we can check if it's in this range, and if it's in this range we need to do something to it. Now let's see what we need to do to it. Well, the uppercase alphabet is here, so we've got A through to Z. And you can see that if you look at the decimal values here, it happens to be that the lowercase alphabet is 32 larger than the uppercase alphabet. So we can always just take away 32 from this character's value and we will get the uppercase character. So happy days. So let's see how we do this. Well, I've got a little bit of code here. So to upper for a single car, assume the character is an A0 following the calling conventions. So what do we want to do? Well, we want to put this to output in V0. V0 is a return address, so we want to put it into V0, but we need to make sure that V0 doesn't have anything stored in it. Because that could influence how we put things in there. So what I'm going to do is I'm going to add V0, value, V0, not A0, the value of A0 with the value 0. So this is just put car to output register. And that's there just in case we don't need to do anything to it. It's already in the return address. We add it with 0 so that we don't manipulate the value. We just get the value from A0. So next, what do we want to do? Well, we want to make sure that we're not out with the range of the lowercase alphabet. So we want to say if we're past the top end of the lowercase alphabet, then we don't need to do anything because we're just some other character then. And if we're less than the value of A in the lowercase alphabet, we also don't need to do anything then. So what I'm going to say is branch less than value in V0, and I think it's OX61 in hex. So that's just saying if you're less than the lowercase a, we don't care, you're not a lowercase character, we've got no obligation to do anything with you, so we'll just go to the end. And then what I'm going to say is branch greater than, again say V0, and this one I believe is OX7a, and if so go to the end, because then we're past the alphabet. So these are just check value lies in lowercase alphabet. Happy days. Now if we fail both of those branching instructions, it's because we're in the lowercase alphabet. So what we want to do is add immediately to V0 the value of V0 and minus 32, and this is convert to upper, and if not, then we should have an end. And in our end, all we need to do is jump register to the return address. Now that's just handing back control to the calling, to the caller. Sorted. Now, this will do it for every single character. So what we might want to do is write a loop which calls this in every single character, or we can call a little subroutine that expects a string and then calls this to upper character. And that's what we're going to do. So this is it up here. Now this all, by the way, is just code for testing at the end, so don't worry about that. But we've got two upper string here. Now, the problem that you might immediately notice is this is assumed that the string, or the address, as it would have to be, is an A0. So one problem we're going to have is that this expects an argument to be passed to an A0, as does this, but they're different arguments and they're of different types. So I can't give a function that expects a character the address of a string, and I can't give a function that expects a string just a character. So we need to figure out what we're going to do there. We also need to worry about the fact that when we're calling subroutines, we have to save the return address between calls because otherwise we're going to lose our place in our code. So we're going to need to use the stack. So what I would suggest we do is we add to the stack pointer a value of -8, and this creates space for 2 words. So remember, each register can store a byte, a word is 4 bytes, adding -8 onto this gives me enough space for 8 bytes, which is of course 2 words. So what are we going to use these for? Well, first thing we need to store is the return address. I'm just going to store that at SP. So this is save return address. And then I need to figure out how I'm going to manipulate a0. So one thing you could think to do is store a0 to the stack, and then you would have it in a safe place, and the stack pointer wouldn't ever come back to it until we call it back, and then we would get our value of a0 back. But since we're writing a loop where we want to check every position in a0 or go through the address of the string at a0, we might want easier access to it, because putting onto the stack would mean loading it from the stack, manipulating it, putting it back to the stack in every single loop, and that might be a bit of a faff. So what we could do is we could use a saved register. Now a saved register, a subroutine has the obligation to restore if it uses it, so we would invite that obligation onto ourselves. But what we would also know is that any other subroutine that we call would have to do the same. So if we put a value in S0, then another subroutine would have to restore it. So what we're going to do is we're going to put S0 onto the stack. So let's store word onto 4 SP. So we put S0 to the stack. It's quite often called pushing onto the stack, and then you pop off from the stack, but you'll get onto that in second year in 207 where you'll wind up programming things like this. So now that I have this, what I want to do, move, no, that's the wrong way around, isn't it? Oh, no, that's in the wrong place, first of all. So we want to put S0 to A0. Now if we weren't using the stack, we would have overwritten S0, so S0 now equals A0. God, I cannot type. We're in week 9 now, all of my mental acuity is gone. Now we can loop. Okay, so what do we want to do? Well, now we would just want to manipulate strings. So to start off with, it's going to be much the same as we always do. So we're going to load byte unsigned into, let's say, A0, the value from the pointer stored at S0. So get car. And the reason we're storing it in A0 is because the function that we're going to call, or the subroutine that we're going to call, needs it to be in A0 for it to function. Now, I want to do my usual branch of equal to 0. If A0 0, we don't need to call anyone, we don't need to do anything, we just need to go to end string. Now I'm calling this end string instead of end just because we have another subroutine in this file which has the label end. So Mars will get upset with us, or MIPS will get upset with us by using a label twice. 0. Done. Happy days. So now what we want to do is we want to jump and link to the value, or to the method, to upper car. And that is our subroutine call. And then that's going to do most of the work for us. So once that's done, we get a value in V0 that we can then manipulate. But if we've updated the value, we want to push it onto the string's memory address so that it's stored there and the string has been changed to an uppercase. So what I want to do is I want to store the byte that's in V0, and I want to store it to S0. So we want to put updated car to memory, and we'll all be happy. And then I can just go back to doing usual MIPS coding that we're all very happy with. Well, we should be very happy with. You might not be, but we try. And that's just increment to get to the next byte in memory, and then I can just jump to loop. And now I need to finish off by doing the end string work. Now I need to undo all of the work that I've done with the stack. So first thing, let's load the return address from stack pointer. So this is get and I also need to restore S0. So we want to load into S0 the value that's in for of the SP, as it was our obligation to do. And now that I've got all that, what I can do is I can destroy my stack frames. And I want to add 8 onto that. So now I can just jump back to the register. And that should be us done. Now if it'll be anything like any of the other takes of this video, we might have messed something up, but let's have a wee look at what we get. So we're calling this to do the manipulation of the characters. This is really just a string manipulation method which happens to call toUpperChar. You could imagine this doing anything else toUpperChar to like count the number, or calling another method which would count the number of occurrences of a certain character or something like that. It's fairly generic. We've just embedded it with this toUpperChar this time. So let's assemble this and run it. So you can see I've got this string up here, so this should convert all of the A's to uppercase, and this B should remain in uppercase. This is just code to print that, so let's assemble. Hope we don't get any errors. Oh, what's happening here? Oh, I'm adding immediate, but that should be add, not add immediate. Well done if you spotted that before I did. And let's run it and hope for the best. So there you go. We've now successfully written a little method, a very simple subroutine in fact, which is toUpperChar, just to convert a character to uppercase. And then we've written a more complex method which has exploited the fact that we can call subroutines from subroutines using the stack to save values. Now the main things I would take away from this are using the stack to maybe save, get you some saved registers that you can use so that other subroutines have to restore the values if necessary. That's quite a useful trick to use, but you need to remember to restore that value once you're done with it. The same you need to remember to destroy stack frames. So as I say, I think I'll upload this in lieu of a video on Lab 4, but if you watch this video you should fairly easily be able to see where the solution for that would come from, because you have to do much less work, but all of the code you would need is in here. So I hope you found this useful. If you have any questions about anything I've covered here today, please do let me know. Thanks.